Okay, so for this question, he has given the coefficient of restitution. What are the formulas of the coefficient of restitution? Coefficient of restitution is the ratio of velocities of separation after collision to the velocities of approach before collision, that is u1 minus u2. Suppose if a ball is been falling on a floor like this, before collision velocity is u1 and after collision the velocity of the ball is going to be the v1, but u2 is equal to v2 is equal to 0 for a floor or the ground. So if I substitute UE will be equal to how much, Nana? That is V1 by U1. The minus of minus will be cancelled because U1 is in which direction? Downward direction. V1 is in the upward direction. So it can be removed here. So what is the value of the U1? V1 can be written as a root over 2g height h1 and initial height is h. 2g height h. So coefficient of restitution formula can also be written as an h1 by h, because the ball which is going to be hit the floor, it returns back to certain height, but that is not your original height. This will be h2, this will be the h. So this relation also, or if this is your h, this will be your h1. This relation can also be used for solving the sums. So according to this one, what height the ball is going to be, right? That means he is asking the h1 is going to be how much. So that is E is equal to 0.5 is equal to root over. What is your height h1? If the height is going to be 32 here. So either you can go for the solving or any other procedure. You can find this one, please. So 0.5 whole square means 0.25 is equal to h1 by 32. So we can multiply this one. h1 is equal to 32 into 0.25 meters. Okay, na? So that is 1 by 4th of this one. 0.25 value is 1 by 4, which is 32 into 1 by 4. That is equal to the 8 meters. So like this also you can able to find out the values by using the coefficient of restitution cases, please. Okay, sir. So now what is the work energy theorem conditions? So work energy theorem. So according to the work energy theorem, total work done will be, so whatever the work that what the total work done is equal to your change in kinetic energy. Work done can be in the different formats. Work done can be external force, work done by the internal forces, work done by something, gravity, work done pseudo force, like this different amounts of the work done. So total work done, that is F into S, or the work done can be written as an change in kinetic energy means half m u square minus half m v square minus this will be the half m u square. This is the work done formula. So under the work energy theorem conditions. So work energy theorem, or since it's a conservative thing, so law of conservation of energy means law of conservation of energy is this one. So that means total energy remains constant. Right, Nana? So whatever may be the shape of the energy, either the kinetic energy will be converted into the potential energy, or potential energy will be converted into the kinetic energy. So in this case, kinetic energy is converting into the potential energy. In some other cases, kinetic energy or potential energy will be written as in terms of the half m u square. How it can be written? You know the famous 8 marks question for the first year, freely falling body, law of conservation of energy. At every instant, what sort of an energy it's going to be feeding? So energy which is coming down is in the form of mgh, even in the last line also. Okay, when the body is projected vertically upwards, then the energy is in the form of kinetic energy. So whatever may be the form of the energy, but it will be neither be destroyed or not, it will be changed to the other formats. So now we do have the different types of the forces or different types of the energies or different types of work done also we have seen.